Now, before we start, let's have this set of numbers. 1, 8, 15, 22, and 29. Now, what do all of these numbers have in common? Let's see. 8 minus 1 is 7. 15 minus 8 is 7. 22 minus 15 is 7. And 29 minus 22 is 7. Now, their differences are common, which is 7. Now, that is an arithmetic sequence. An arithmetic sequence is a set of numbers where the difference, or D, of each consecutive terms is always a constant. And when we say constant, it never changes. Now I have here sets of numbers, and we are going to determine if they are arithmetic sequences or not. Let's have the first one. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. And 11 minus 9 is 2. The differences between consecutive terms is a constant. Therefore, it is an arithmetic sequence. Let's have the second one. 11 minus 7 is 4. 15 minus 11 is 4. 19 minus 15 is 4. And 23 minus 19 is 4. Therefore, it is an arithmetic sequence. Next, we have this. 6 minus 4 is 2. 9 minus 6 is 3. 13 minus 9 is 4. And 18 minus 13 is 5. Their differences is not a constant. Therefore, it is not an arithmetic sequence. Let's have the different formulas that we could use in solving arithmetic sequences. The first one is the general term, and it says that a sub n is equal to a sub 1 plus n minus 1 times d, where a sub n is the last term, a sub 1 as the first term, and n as the number of the term. Now you already know that D is the common difference. Next, the next one is the recursive formula. And in this formula, a sub 1 is always given. And to find the next term, we have to use the formula a sub n is equal to a sub n minus 1 plus d. Next, we have the explicit formula, and it states that a sub n is equal to b times n plus a sub 0, where a sub 0 is the term before a sub 1. So to get a sub 0, we could just simply minus the common difference with the first term. Now let's use the different formulas in finding the sixth term in the sequence 7, 11, 15, 19, and 23. Let's first use the general term. a sub 6 is equal to a sub 1, which is 7, plus quantity n, which is 6, minus 1, times b, which is 11 minus 7, which is 4. Now, 6 minus 1 is 5, times 4 is 20, plus 7 is 27. Now let's see if it's correct when we use the recursive formula. A sub 6 is equal to a sub n, which is 6, minus 1, plus d, which is 4. Now, a sub 6 is equal to a sub 6 minus 1, which is a sub 5, and a sub 5 is 23, plus 4 is 27. Now, let's use the explicit formula. A sub 6 is equal to d, which is 4, times n, which is 6, plus a sub 0, which is 7 minus the common difference, 4, which is 3. Now, a sub 6 is 6 times 4 is 24, plus 3 is 27. Now, they all matched. So, a sub 6 is definitely 27. Now let's have two sample problems involving arithmetic sequences and their formulas. In the first problem, we are asked to find the 18th term of the sequence 21, 24, 27, 30, and so on. So let's use the general term a sub n equals a sub 1 plus quantity n minus 1 times d. Now, a sub 18 is equal to a sub 1, which is 21, plus n, which is 18, minus 1, times d, which is 24 minus 21, which is 3. Now, 18 minus 1 is 17, times 3 is 51. And 51 plus 21 is 72. So, 72 is the 18th term. Now, what if the common difference is the one missing? We have here a sub 10, which is equal to 17, and a sub 14, which is equal to 30. Now, we could use the formula d is equal to the change in a over the change in n, where the change in a is equal to the difference between 30 and 17, and the change in n, which is equal to the difference between 14 and 10. Now let's write that down. 30 minus 17 over 14 minus 10. Now, 30 minus 17 is 13. And 14 minus 10 is 4. Since the fraction is in the lowest term, then 13 over 4 is the common difference. Now let's have the arithmetic series. Now the arithmetic series is the sum of the terms in an arithmetic sequence. Now we have to derive a formula for it, since it's going to be a hard time adding such many terms. So let's use a representation of a sequence, or a series rather, S sub n is equal to a sub 1 is the first term, plus second term would be a sub 1 plus d, and third term would be a sub 1 plus 2d, plus, and the last term would be a sub n. Now we are going to be adding it to another S sub n, but this time a sub n would be the first term, and the second term would be a sub n minus d, since it is reversed, plus a sub n minus 2d, and the last term would be a sub 1. Now let's add it all. 2Sn would be a sub 1 plus a sub n, plus this would be cancelled, and this would be cancelled as well. A sub 1 plus a sub n plus dot 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 plus a sub 1 plus a sub n. Now, how many of this term would we have? We're going to have n terms of it. So 2s sub n is equal to n times a sub 1 plus a sub n. Simplifying, we would have s sub n is equal to n over 2 times a sub 1 plus a sub n. This would be the first formula that we're going to have for the sum. The second formula would be when the last term is not given. Now we could recall that the general term is a sub n is equal to a sub 1 plus quantity n minus 1 times d. Now we could simply substitute that to a sub n. We have s sub n is equal to n over 2 times quantity a sub 1 plus a sub 1 plus quantity n minus 1 times d. Simplifying, we would have s sub n is equal to n over 2 times 2a sub 1 plus quantity n minus 1 times d. And this would be the second and last formula. Now let's try to solve some problems involving the formulas for summation. Now let's first add 5 plus 9 plus 13 plus last term would be 101. So first we have to determine n, or the number of terms. So we have to use the explicit formula for it to be. So we have 101 equals common difference, which is 9 minus 5, which is 4, times n plus a sub 0. 5 minus 4 is 1, so a sub 0. Transposing 1 to the other side will give us 4n equals 100. And dividing 4 to both sides, we would have n equals 25. And we're not done yet. We still have to use the formula for summation in order to get the sum. So we have s sub 25 equals 25 over 2 quantity 5 plus 101. So 5 plus 101 is 106. Now multiplying 106 by 25 halves would give us 1325. That would be the answer to our first problem. Next, we have the summation of 2n minus 1, where n starts from 1 to 100. Now, we all know that 1 would be the first term if it would be substituted to n, and 100 would give us the last term when substituted to n. So, let's write it down. A sub 1 would be 1. And A sub 100 would be 199. So, we will substitute these variables to our summation formula. One plus 199 would give us 200, and 100 over 2 will give us 50. So 50 times 200 will give us 10,000. It's as simple as that. Now here is a technique to help us remember the formula always. Now first, let's get the first three terms of the sequence. It would give us 1, 3, and 5. And now let's get the last three terms, which will give us 195, 197, and 199. Now, when we add this and this, it will give us 200. When we add this to this, it will also give us 200. And when we add this to this, it will also give us 200. It gives us an exact same amount of 200 up to the middle. Now when we add the outermost terms inward, it will give us the same answer. So definitely 200 times, how many terms or pairs would we have? Since there are 100 terms, we would have 50 pairs. And that would give us 10,000 as the summation of the first 100 terms. Now, let's have a challenge problem. How many terms of the arithmetic sequence 1, 3, 5, and so on will give a sum of 961? So, for us to avoid confusion, let's first list the possible given that we could use. We have A sub 1 is 1. D would be 3 minus 1 is 2. And the summation of n is 961. And we are asked to find the number of terms, or n. Now, we could use the other formula for summation, which is the longer one. S sub n is equal to n over 2 quantity 2a sub 1 plus quantity n minus 1 times d. Now, let's substitute the values that we got. S sub n is equal to n over 2 times 2 times 1 plus n minus 1 times d, which is 2. Now simplifying, we get n over 2, 2 plus 2n minus 2. This would be cancelled, and this would be cancelled. And now we're left with s sub n is equal to n squared. And we all know for a fact that s sub n is 961. So n squared is equal to 961. Now we just need to get the square root. The square root of 961 is positive or negative 31. But we are asked to find the number of terms, and it could not be negative. So n is equal to 31 terms. That's all. Thank you.